In the previous lesson, we talked about how to determine empirical formulas from percent comp. And in this lesson, we're just going to take that one step farther. We're going to determine molecular formulas, which are multiples of empirical formulas from percent comp. Before we take it all the way, we're just going to go from an empirical formula to a molecular formula. So the first thing we want to do is make sure that you recall what an empirical formula is and then compare it and contrast it with a molecular formula. So in regard to empirical formula, what's an empirical formula?
Simplest whole ratio of something.
Simplest whole number ratio of atoms or elements in a compound. It can be covalent or ionic, but we'll do more with the covalent compounds. So a molecular formula tells you not only what atoms are in the compound, but how many of each you really have. A molecular formula is a multiple of the empirical formula, and we're going to figure out what that multiple is and how to apply it. Now, in some cases, molecular and empirical formulas are the same if the multiple is 1. So a molecular formula is some multiple of an empirical formula, n being that multiple, it's a whole number such as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, not 0. In looking at the chart shown, you have 3 compounds: formaldehyde, acetic acid, and glucose. And all of these compounds have the same empirical formula, CH2O. We can determine the empirical formula mass very simplistically using mass numbers. So we don't need to get detailed with it. We can just do it from mass numbers. For example, all of those substances had the empirical formula CH2O. And so the empirical formula mass can be determined very simplistically. You have 1 carbon times its molar mass, and we're just going to use mass numbers, so we rounded it, plus 2 hydrogen, each at 1 gram per mole, plus 1 oxygen at 16 grams per mole, for a total of 14 plus 16 is 30 grams per mole. So the empirical formula mass is the mass of 1 mole of empirical substance. So each of these substances has an empirical formula mass of 30 grams per mole. That's how you determine empirical formula mass, very straightforward. The molecular formula for each of these compounds is provided. Some of you in your projects did acetic acid. So formaldehyde also is CH2O, same as the empirical. Acetic acid is C2H4O2. What's the multiple to go from acetic acid's empirical to molecular formula? 2. Glucose, which is a simple sugar, simple monosaccharide, is C6H12O6. What's the multiple to go from glucose's empirical to molecular formula? 6. So by looking at the empirical and molecular formulas, you can easily get these multiples. You also can get the multiples by comparing their molecular masses with their empirical formula mass. We've talked about how to get empirical formula masses already, and we've done molecular masses at the beginning part of this chapter. So to calculate N, you can do the molecular mass over the empirical formula mass. Now this was a simple rounding, so when you divide you may not get a perfect whole number, but you're going to get something very close. So 30 over 30 is 1, 60 over 30 is 2, 180 over 30 is 6. So you also can get the value of N by dividing the molecular mass in grams per mole by the empirical formula mass in grams per mole. And that's what we're going to be doing here. Initially, you'll be given the empirical formula. You will calculate the empirical formula mass from mass numbers. You'll calculate n by doing molecular mass over empirical formula mass, and then you'll apply n to the empirical formula to get the molecular formula. So those are the steps we're going to be using. Again, determine the empirical formula if not provided. In the first two examples, I've given it to you to keep it very simple, but you already know how to determine the empirical formula from percent comp. So that may be something you're asked to do as well. Calculate the empirical formula mass as I've shown you. Calculate n, molecular mass, over empirical formula mass. Write the molecular formula by applying that multiple n to the empirical formula, and we'll go over that. So let's walk through these first two examples. We want to determine the molecular formula of a compound, so that's what we're looking to do. It has an empirical formula of CH, and the molecular mass is 78 grams per mole. So that's the information that is provided, and let's take a look. So we want to know the molecular formula. That's what we're looking for. The empirical formula is CH, and the molecular mass is 78 grams per mole. So that's what's given. So the first step is to determine the empirical formula. Step A, that's already been done for you, making life a little easier. In step B, you want to calculate the empirical formula mass. And again, we did that previously. We have one carbon at 12 grams per mole and one hydrogen at 1 gram per mole. And so the empirical formula mass is 12 plus 1 is 13 grams per mole. And what should we do next?
78 divided by 13.
We're going to find N. It's going to be the molecular mass over the empirical formula mass. And that's going to be 78 grams per mole over 13 grams per mole, which is 6. And now we're going to apply the N, the multiple, to the empirical formula to determine the molecular formula. So the empirical formula is CH, the multiple is 6, C6, H6. And that is my molecular formula. That's actually benzene. Has a cool structure. Looks like that.
That was close.
Double bonds. Corners represent C's, and then you've got an H hanging off each one.
Like that.
Just like that. Perfect. You don't need to know that. It's just interesting. Incidentally, if you like to read, Robin Cook wrote a really good book years ago called Fever, and they were talking about like dumping in certain areas and how kids were coming down with cancer. It was very good. I liked it. All right? Very straightforward. You want to try the next one together, or you want to try it yourself?
Ourselves.
Okay.
Are you kidding? I don't understand that at all.
You just multiply it.
I'm feeling confident.
All right. At the top of the screen is this problem, and I will help you. Who needs help? You two? You can't do it?
Oh, I can do it.
So what do you need help for?
Oh. Just kidding.
Sebastian, can you do it or you want help?
It's generally.
Yeah, I second that.
You second one.
I kind of like.
You want to do it together?
Sure.
Together, I don't
Together? Okay, we'll do it together. Together forever. Here we go. It's all right. We can do it together. It's good. This one says, determine the molecular formula. For those of you who can do it, you go rock and roll it out and just check off mine. The empirical formula is given as C2H3N, and the molecular mass is 164 grams per mole. So that's what's given. That's what you want to know. So Dean, what's the first thing we should do? Find N? I'm not ready to find N yet, but we will soon. We've got the empirical formula, so we can find the empirical formula mass. So here's step A. Step B, empirical formula mass. How do we do that?
Yeah, that's my question. Where do we get those numbers from?
Periodic table.
Oh, okay.
They're just rounded atomic masses.
Oh, okay.
Yeah, whole numbers. So 2 times 12 grams per mole plus 3 times 1 gram per mole plus 14 grams per mole. You only have one N.
Let's forget those numbers.
Yeah, 24, 27, and 14 is 41 grams per mole. So this is the mass number of carbon. This is the mass number of hydrogen. And this is the mass number of what? Nitrogen. And this is how many of each of those you have. Now, Dean, we're going to get N. How do we determine N? The molecular mass, the big number, over the empirical formula mass, which is typically smaller, it'll never be bigger. So that's 4. What was the empirical formula? C2H3N. What's the multiple? C8, H12, N4. All right, so you've got the empirical formula, the empirical formula mass, how many of each atom times its mass number. Just to make it easy, if you want to do the molar mass 12.011, it's fine, but it's not necessary. Here's your empirical formula mass. Your N is your molecular mass over your empirical formula mass. Apply the N to your empirical formula, and now you have a molecular formula. Some multiple.
So like on the last, I don't know if it works, but for the last one, you have to time the multiple. It's not.
I can't hear his question. Excuse me.
If it's not like a whole number.
It will be. It will be a whole number or really close. It might be like 3.01. If you come out with 3.5, something's wrong.
Oh, for.
It'll be a whole number or really, really close to it. And it can't be a fraction. If it's a fraction, you did it upside down.
Oh, okay.
All right? So it'll be a whole number. All right. That's the piece of molecular formula you didn't have. The only way to make it more challenging, which I definitely did on your semester exam, figuring one problem to cover both, is on your semester exam I gave you a problem more like the last two in your notes, and we'll go through at least the first one together. What you're going to see here on the screen is I'm asking you for the molecular formula from percent comp. So if you're asked for molecular formula from percent comp, you first go from percent comp to empirical. The molecular mass is given, so then you can go from empirical to molecular. So this is just a matter of putting everything together that we talked about. So in this problem, it says oleic acid. I don't know how many of you watched the movie Lorenzo's Oil.
Oh, I saw
Remember?
That was depressing.
that.
So it was a little depressing. The chemist, remember the elderly gentleman who was the chemist?
Yeah.
And he found that oleic acid was the substance that had the most curing effect. And oleic acid is something we're going to determine the molecular formula of here. So oleic acid, it turns out, contains carbon, hydrogen, and oxygen. The percents are provided. The molecular mass. The molecular mass of the substance is 282 grams per mole. And they're asking for the molecular formula. And again, you have to recognize the problem in that you need to find the empirical formula first. So this is just a matter of putting everything together. So let's get the information down. We'll work it. And then hopefully you'll be ready to practice, 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 because that's the only way to master chemistry. All right. So what we're looking at here is we have 76.54 instead of percent grams of carbon, 12.13 grams of hydrogen, 11.33 grams of oxygen, and we'll write down the rest of the information in a bit. We're going to go from here to the empirical formula the same way we have done the other 6 problems that we've done today. First, you're going to convert grams to moles. So we get moles of everything, and you should be very comfortable with the mass to mole conversion at this stage of the game. What do we do next? Divide by the smallest number. So I get 8.997 moles of carbon, (16.99 moles of hydrogen, and 1 mole of oxygen. And I check to see if these are within 0.05 of a whole number, and they are. So this would be 9 moles of carbon, 17 moles of hydrogen, 1 mole of oxygen, and my empirical formula is C9H17O. That's my empirical formula. All of that is step A. So once I get the empirical formula, then I swing into the molecular formula aspect. What do I do next? Once you have the empirical formula, you need to get the... You have the molecular mass, you want to get the molecular formula, but what do you need to do? Empirical formula mass. So that's going to be 9 times 12 grams per mole plus 17 times 1 gram per mole. We're just using mass numbers as we've done 3 times already, plus 16 grams per mole. And that's going to be 141 grams per mole. That's the empirical formula mass. Next, we're going to calculate N. N is the molecular mass that's given at 282 grams per mole over the empirical formula mass. And so that's 2. N is 2, a whole number. How do you get the molecular formula? Go ahead.
Wait, the formula?
How do you get the molecular formula? You have the empirical formula, you have the N.
Like the number of the...
The molecular formula, C something, H something, O something.
Oh, multiply by 2.
Multiply by 2. Good. C18, H would be
34.
34 is correct. O would be 2. That's my molecular formula. Now you're done. That's what they asked you for. They gave you molecular mass. That's what you used to determine your N. Guys, we have 13 minutes in the period. There is no reason to pack up yet. You need to utilize every minute you have in here.
Wait, so what's the final answer called? Like
That's the molecular formula. So the molecular formula here, which I have labeled as such, is C18, in the back please, C18, H34, Sebastian, really, C18, H34, O2. That's your molecular formula. If you can do... If you can do the last problem in the notes, you have some understanding of how to do this. By the time you get through all of the classwork, you will be golden on this concept. Your goals today were to understand empirical formula and molecular formula. What they are, how to determine them. This problem, like the one we just did, or especially the last one in your notes, is worth 10 points on your semester exam, and you'll see at least 15 points of this, if not 20, on your next test. On your semester exam, I hit the mole concept hard in part 2, and I hit drawing with shape hard in part 2, because I felt those were the things we had just covered and that you would be extremely strong with them. Dean?
How many total points is this semester exam?
I'll hit that in a sec. Question here? Okay, so empirical and molecular formula all fit into this mole concept that we've talked about now for 2 weeks. Please make sure that you do this problem as well as the problems in your classwork. You can do all of your classwork at this point.